Hi, I'm Gail Locke McDowell, author of Cracking the Coding Interview. Today I'm going to talk about tries. This isn't something CS students might have spent that much time on in school, but it's really, really important for interviews.
A trie is a data structure that is actually a type of tree, but it's often used to store characters. And the way that it works is each node might store just a character as its data, but then if we look at the path from the root down to that node, that node is really representing a word or a part of a word. And so what it allows us to do is very quick lookups of a particular kind. So for example, suppose we use this trie to store this very small version of the English language. We could use it to say, hey, are there any words that start with CAR? Yes, there are. There's car, that's actually a complete word, but there's also card. So car is also a prefix. So it allows us to do very fast lookups. So let's talk briefly about the implementation of it. So we're going to need a class node. And then rather than having, as we would in a binary search tree, a pointer to the left and right node, instead we have some sort of either array of all the children, or more likely some sort of lookup table that maps from a character to that node. So we can immediately say, do you have a child that is an A? Great, give me that immediately. Additionally, we need to understand not just is there do you have an R as a child, an R node as a child, but is that actually a complete word or is it just a prefix? And so in addition to each node having a mapping of from character to node, each node also has some sort of flag in it called something like is complete word that represents, is that a complete word or not? We see tries in a lot of problems. So if you're in an interview and you get a question that has some sort of word validation to it, so, check if this is, walk through this table and find all walk through this Scrabble board and find all the words, or given this list of strings, find all celebrity names. So when you see something that has some sort of word list validation, think about whether or not a trie might be useful. There's one optimization that often comes up in trie problems. Suppose you had a situation where a user was typing a word, and as soon as the word became clearly was going to be an invalid word, you want to say underline it. So someone types C, and you say, yes, that is in fact potentially going to be a valid word. And then someone types CA, okay, great, we're looking good. Now they type CAL, yes, okay, there's words that start with CAL. Now they type CALP, oops, no, that's an error. So that's a good case to use a trie. Now the way that I've explained trie so far, you would do each of these lookups from scratch. You'd say, is there a C? Is a valid prefix? Yes, there is. And then you do, is CA a valid prefix? And you'd start from scratch over at the root. Now, in a lot of cases, though, we actually want these calls to kind of build on each other. So one thing we can do with our trie is we can keep state in various ways. So when we look up, is C a valid prefix? We actually store where we are in the tree. So when the user types the very next character in A, we just look immediately, is A a child rather of C? Of that last lookup, rather than starting from scratch. And there's different ways you can actually implement that. One way you can do it is to actually keep state within the trie. Another way you could do that is actually return the node back to the caller. So when I say, is C a valid prefix, I get not only that it's a valid prefix, but I also get information that gives me exact reference to that node. Then, rather than starting from the root and saying, is CA a valid prefix, I just ask, is A a child of C? And then I ask, is L a child of the CA? Et cetera, et cetera. So again, tries are not something that you would spend a lot of time in algorithms classes or in algorithms textbook. And so they're unfamiliar to some people. But it's a very, very common data structure for a lot of interview questions. So keep an eye out for that construct or that frame of a problem that says something about validation of words, because that's often where we're going to want to use a trie. So now that you've understood the basics of a trie, why don't you try applying this to a new problem? Good luck.